This is an RNZ podcast. Piki mai kake mai, and a very big welcome to Elemental. In this RNZ podcast, we are celebrating the 150th birthday of the periodic table. I'm Alison Ballance from RNZ.
And I'm Professor Allan Blackman from the Auckland University of Technology.
Well, we're up to episode 10 already, Allan, and after our blockbuster effort last time with the heavyweights, have we got something a little lighter this time?
Well, in fact, a lot lighter. We go from the very bottom of the periodic table right to the very top of the periodic table. We're going to be talking about beryllium today.
Oh, now wait a minute. Hydrogen, helium, lithium, beryllium. So I guess that it's number 4 on the periodic table from my infinite knowledge of the periodic table. So what kind of story do we have with beryllium today, Allan?
Well, it's a tale of something sweet and precious, but deadly.
So the precious thing, I assume beryllium has got something to do with the gemstone beryl?
Indeed it does, and kind of interesting this because beryl itself is colourless, so it's sort of got beryllium and it's got aluminium and silicon and oxygen in there, and if it were colourless by itself then it would be pretty boring. But what we find is that in fact when we talk about emeralds, or we talk about red beryl, or we talk about aquamarine or morganite or golden beryl, in fact, they're all beryl, the mineral, but containing small amounts of different, what we call transition metals. And so, in the case of emeralds, for example, we've got chromium in there that gives it the beautiful deep green colour, in fact. So, beryllium, that's the precious side of it. A lot of these precious stones are actually based on beryl.
So what actually is beryllium then?
So beryllium itself is a metal, and a very, very light metal, I guess the second lightest after lithium. It's kind of interesting in terms of its name because it was originally called glucinium. And if you can sort of see the link to maybe glucose in there, glucinium was chosen because apparently beryllium and beryllium salts taste sweet.
So this makes me think of something else. So lead is also sweet, and you'd mentioned it was sweet and precious but deadly. So lead is toxic. I'm guessing beryllium might be as well.
Indeed. Lead acetate, I believe, sugar of lead as it was called. Beryllium also highly, highly toxic, in fact. Very, very nasty, especially the dust. So obviously when you're mining these sorts of things, you want to be very, very careful, and playing around with these things in the laboratory. There are very few chemists actually in the world who do play around much with beryllium just because of the fact that it is quite so nasty.
Right, so I'm avoiding it in a chemistry lab. I'm also trying to avoid it in real life. Where might I actually come across it apart from, say, a jeweller's shop on some encrusted ring or a really expensive necklace or something?
Well, that's the thing. I mean, don't go throwing out your emeralds or anything like that thinking that they're horribly toxic. They're not. It's just that if you start grinding them up or anything and inhaling the dust, that's when they're going to be nasty for you. But the mere fact that beryllium salts are pretty toxic, it does limit its use, certainly. It finds use in X-ray tubes because what we find is beryllium is so light that essentially X-rays go straight through it. And it was also very, very important in the discovery of the third elementary particle, I guess, in the atom, which was called the neutron. And this was discovered in 1932 when one of Rutherford's students decided to take beryllium and shoot these alpha particles at beryllium, and what he found was that neutrons were given out. And this was a huge, huge discovery because neutrons could then be used to get big nuclei to undergo fission, and thus the atomic age was born. So beryllium, fairly directly, I guess, involved in the development of the atomic age.
Am I right in thinking its golden age is not quite over yet?
Indeed. They're going to put up a replacement for the Hubble Space Telescope in a couple of years, and this is called the James Webb Space Telescope.
All the astronomers are waiting excitedly for that.
And its mirrors are going to be made of beryllium. The reason being that, again, as I said, that it's a very, very light metal, but it's also very, very, very strong, and it doesn't deform over a wide range of temperature, because when you're out there in space at a temperature of minus 220 degrees Celsius, having come from Earth at a temperature of Earth temperature, then you want to make sure that things don't change their structure too much. And indeed, beryllium's perfect for this. So when that goes up in 2021, it's going to have a fair bit of beryllium on board.
Whoa, talk about glitter and glamour. That's like the world's largest gemstone. I bet that cost a bit.
And certainly not one to wear on your ring finger. So that's us for this episode. Next time on Elemental, we'll be talking about bismuth.
Whatever that is. This is an RNZ podcast, and you can subscribe to us at all the usual places: Apple Podcasts, Spotify, Stitcher, Radio Public. I think that's all I can think of at the moment. You can also check out our webpage, rnz.co.nz/chemistry.
Catch you next time, but until then, I'm Allan Blackman.
And I'm Alison Balance. Kia pai tō rā.
No, dog.